Hey, Paddy and Lucas here. Gonna talk about our C++ CA2 game. So first thing you're gonna need is you're gonna need to go to this website here, PostgreSQL, and download. You want to go to Windows, go get this pgadmin3, and you want to download the latest version of this installer, and then you install it. When you do install it, you're going to have to make sure that your database, your Postgres password is just password. I'll show you on screen. This here, you want it to exactly be password lowercase, or this your database won't work. Next, you need to open up your pgadmin. You go to Postgres, you go databases, and you go new database, and you have to make sure this one is called game DB with capital G, capital D, and B, and you just click OK, and whatever comes up, it's all just standard. You just need that set up. We'll come back and talk about that in a minute. Then what you want to do is you want to have you've got mudgame and populate database. What you want to have is you want to have your populate database as your startup setup project. Now for you won't need to have this commented in. We'll have it commented out for you. It's drop tables from database, but we're going to use it because we already have some set up in our. I'll bring it back in. You can see here we already have some set up in our. Sorry, I didn't mean to click that. We have some set up down here. Some tables, enemies, items, players, rooms. So we'll just run this now. So there you go. That'll just show you. That's just when that's done. That means that it's all populated. So what you do is, so you want to go to your tables, and what we're going to look at is players now. But first, you want to click refresh. You want to right click on players. You want to go view data, view top 100 rows, and here you can see all your players who are added in. We've got just a few tests in here. We've got 2 admins, a gold, and a regular, just so we can test out all the different features. So that's your Postgres setup. Next, we're going to move on to the main game, mudgame. So what you want to do is you want to set it as your startup project, and then we'll run it, and I'll just run you through the game. Okay, so that's the server running now. So what we're going to do is we're going to bring in 2 telnets so we can game. So what we're going to do is we're going to set up a new. Why is this not? There we go. We're going to set up this just to a new so you can see the trainer. So we're going to create Anna. And it takes you to the training handler, so you can just update your character. So now we've got no points left. We click quit, and it brings us into the world. So now, as when we're Anna, we want to look at our stats. So we have 2 ways of doing this. We can check stat, or we can check X. So those are just the commands and the shortcuts just to show you that there are. So what it does is it tells you your name and what your rank is, your health, your strength, your agility. It also tells you what you have equipped, your weapon and armor, which is a feature we haven't implemented yet, but will do for the next deadline. And inventory, you've got like 10 items that you can store, keep with you at all times. The empty entity name is just for debug, so we can tell that it's actually empty and there's nothing in it. So also we have a help feature, so you can check all your commands. It's a bit of a mess at the minute, as you can see, but these are all the commands that we want to implement into the game. Some of them work at the minute. We're going to tidy this up for the next deadline. So now we're just going to assign another person in here. I'll assign myself in just for some of the next features. We'll come back to Anna. She can see that Paddy has entered the realm. So we're just going to see who, right? So who is one of our commands that we can type, and it just shows you who's online. So it shows you that you and Paddy are online. But if you type who all, it will show you everyone in the database. So including Anna. So next, Anna is going to chat. Hello world, and it just shows you that both people can see it. So Anna can see it herself, and everyone else in the game can see it. The next thing we can show you is change command. So what you can do is you can change so the help command, you can change it, but all it changes is the shortcut. So say you want to change that to HE, So it used to be H as the shortcut. That doesn't work anymore. But it types HE and then the help commands will come up. One thing to note over here is that in the debug you can see that it happens. So command help shortcut set to HE. So that just shows you. Okay. Okay, so next we're going to show you the move. So you can type in north, south, east or west, but it's just easier to type north. And when we go into this room there's going to be some enemies that you can attack, and you can kill them and they can kill you. We're just going to kill them as soon as we go in though, and just start attacking them until the room is empty. So you've killed, there's not, and then it shows you there's nothing to fight in this room. But that's how it happens. And then another thing we can do in here now is we can look around the room. And now you can see that although there were enemies in here, I'll show you that in another room next. There would have been a list of enemies here. Now there are items that we can pick up and money that we can get. So if you type get, you picked up all the money, so now it's taken out of the room. Or you can type pick and it will pick up the first item in the room. So if we go look again, you'll see that there's one less sword at the top. Another thing we can do is, now that Paddy is an admin, I'll just show you that you can promote. Make sure I spell this right. Promote Anna. Maybe I spelled her name wrong. Oh, I spelled promote wrong. Sorry, that's what it was. So now Anna has been promoted. So if we check her stats, you can see that she is now a god. And if we scroll back up, I should have pointed it out earlier. Maybe it's not there anymore. That sorry, it's gone past. Yeah, but Anna was just a regular player because she was added in. But if we demote her and then we check her stats again, you can see that she's now regular. Next we talked about attack, pick, get. Okay, so the player can die. We'll move to a room where you can get attacked. Maybe no, there's no enemies in this room. No enemies in this room. Oh, no enemies here either.
Go north.
Yeah, go north. Can't go north. Principal's office. It doesn't matter. You can die in the game. I'll show you here. I'll move Paddy forward. Enemies here. They're hitting you. There, you got knocked out, and you're moved back to the front hall. At the moment, the only penalty is being moved back, but we're going to implement. You might lose some money or an item. Okay, and we're going to talk about the shutdown. So here's Anna. She's a regular player. She types shut. She doesn't have permission to do this. Either does it have a god, but Paddy, who is an admin, he can shut down the entire game. And it closes the connection. Okay, now we're just going to run through some of the code. Okay, so some of the stuff I worked on the populating the database. So, oh, we're already here, yeah. So I worked on the dropping the tables, the creating tables and populating tables. All the drop tables does is the drop tables will drop any of the tables you already have. Like I said, you probably won't have to do this, but it just passes an SQL command into a session, which is a part of the SOCI library, or SOCI library, SOCI library, and it will parse this SQL command and or put this SQL command in and drop the tables. And the create the tables is fairly similar, but it will create the tables for these, and it will pass in what they need, and it'll set their like primary keys, what their the database values are, like what we were talking about earlier. It'll basically create these for us. And next we have the populate tables. So they basically they're all very similar, but so I'll run through like what populate players, how it runs. So populate players, you create a vector of players that you want to insert into it, and you create a standard player, and then you set them up. So you create their ID. Every ID has to be unique, and every name has to be unique. You can set their rank, their name that will appear on screen when they're in the game. I think if you notice, even though I was called Paddy in the game, I accidentally had my name set to Lucas. So you can see in there you can have nicknames basically and usernames. You set your stat points, your current health, your regen amount, all your details. You give them money, what room they're in they start off in, which is kind of important. you pass them all in, you create all your players, and then here's a C++11 feature we used. We used auto, so uh, for all the players into insert, which is like a vector of players. So for all the players in this vector, you pass them into their respective tables. So for this one, it'd be you pass them into players. So it takes each ID and passes it. Oh, sorry, each value and passes it into the correct one. So here would be ID into ID and name into name. And I'll just scroll through so you can see it. Oh, sorry, I'll talk about get players from database as well first. So this will load in the players from the database. This is the opposite of saving them out. This is loading them in. So you'll have a count of players. So what it does is it makes sure it knows how many players were in players, and then it will create a vector of players, and it will reserve a space of that count. So the size of that count, and then for each player. For each player in the vector, it'll add them in from the database. But what I was going to say is it's basically the same for populate items, rooms, and enemies. What it does is it has a vector of items, rooms, or enemies, creates an item, inserts it into that vector, and then for all the items in that vector, it's the same, and it's the same for enemies and rooms. Next, I'm going to talk about the attacking. So that is in whereabouts is it? It is in commands. Where are command functions? Okay. So here are some of the commands, and I'm going to talk about some of the ones I worked on. So attack. Let's go to attack. So yeah. So a player has an attack called fight enemy. So first of all, it will check if there are any enemies in that room, and if there aren't, it'll say there's nothing to fight here. But if there are, you go into player's fight. You'll parse this command, sorry, but attack, by the way, with a player. So you'll go into fight enemy. What fight enemy does is it checks if it'll hit the enemy, and if it doesn't, it'll say you missed. But if it does, first of all, it will calculate how much damage it's going to do on the enemy. Currently, how that works is if your base stat is less than 0, it's not going to give them health. So a negative minus a negative, it's just going to instantly return 0. But if not, it will. If it's greater than 0, it'll go in and it'll check your base stats against the enemy base stats. If they're the same, there's going to be no additional or subtracted damage done, so you'll just do whatever your strength is to their health. But if yours is higher or lower than theirs, what it will do is it will generate a value dependent on your strength and their strength. So if they're stronger than you, it's going to be your attack is going to be weaker. But if it's stronger, it's going to be stronger this time. The only problem with this would be if the enemy strength is set to 0. This is a divide by 0, so it's going to fail. But we've just set it up so it won't. And also, if your strength is set at 0, but it's going to return 0 because it never gets through here. Next thing it does is it inflicts damage on enemy. So what it does is it passes in the enemy and the damage, and it just takes that away from their current health, and then it tells you you've hit that enemy for this much damage. Then it will check if you've killed the enemy, and if you have, it returns true, and if you haven't, it returns false. It usually will return false in this case. Attack, go into this again. So if it returns true, it will tell you that you've killed this enemy, and then it will put items on the floor and put money on the floor, and then it will pop that enemy out of the room. So when you go to attack, the next time you type attack, if the room is empty, then there will be no one to fight. What else have I worked on? I have worked on player death. We'll go to movement first. I worked on movement. So I'll just speak about go north, go south, go east, and go west. They're very similar, but there's only one difference in each of them. So first of all, you get the ID of the exit. So in this case, you'll be looking for the north exit. so you check the player's room reference, finds out what room they're in, then it checks their exits and gets the north, side, east or west one. And if that's equal to 0 or less than 0, it will say you can't go north, because we have our databases set up. I'll drag one in for you now. Rooms, view data, top 100 rows. So as you can see, we have them set up so they have an east, north, south, west integer, and front gate is a good example, because if it east, south, and west are all set to 0, you can only go north. And you can see this because it's room 2. You go south from the front hall, so that means you can always go back north to the front hall. And if you can move in that direction, first of all, it will remove that player from that room by getting the room reference of the player, remove player by their ID, and then print room is just a debug, and then you set the room pointer from the room that you're in now, which is the ID that you moved to because of this here, and then you set your room ID to that, so that will generate enemies for the room. Here, if empty, generate enemies. And then what you next want to do is you want to store the player. So I can just show you actually the remove and the store player. Skipped over that. So if when the player leaves the room, if the room is empty, if it tries to remove a player from an empty room, it can't do that. The room's empty. But else it will. Again, here's the C++11 feature. It will auto. It's an auto, sorry. So it will for loop rend this players in room list, which is it's in the room.h. I'll show you that in a minute. It's a list of players, and it'll go through it from beginning to end. And if when it finds the player, it will erase it using the ID, basically the iterator. It'll remove the player from the room, and then it will return. Sorry, I'll jump in here again. And store player works by it'll just, when the player enters the room, it'll just pop it into the players in room. It'll pop its ID, sorry, into the players in room list. Go north, and that's basically north. It'll then it'll print off the room that you're in, so you know that you moved. Populated movement room player. The player debt, I'll show you that. I'll show you how the enemies attack and the player debt now, which happens in the game loop. Where's the game loop? Did I pass it? Game loop. So the game loop, now is the time that is set at when the program initializes, and it will update itself as the loop goes round, and then it will check. So if now is greater than or equal to next round, and next round is initialized alongside now, so it's equal to now at the start. So when the program is initialized, next round and now will be the same. So if this is true, which it will be the first time it comes round, it will perform an enemy attack, and then next round will add on round time, and round time is a time that Lucas has is a function that we'll call a function that Lucas has created called seconds to milliseconds, which he'll talk about later, and it just converts the time, so it's easier for us to code. Constant expression is another C++11 feature, and Lucas is going to talk about it later, but just to point out that it's there. So then we go to perform enemy attack, so we'll jump down to it. So perform enemy attack, all it does is it will call the map and will say all enemy attacks, and the reason it calls the map is that it checks every room in the game. The map is basically a list of all the rooms. So we'll go to all enemy attacks, and all enemy attacks has again an auto, a C++11 feature that I'm gonna point out again. So for all the rooms in all rooms, which is I believe it's a list, it's a vector. It's a vector of all rooms. So it will go through for all the rooms in rooms. It will call the enemy attacks. And here's where the real work kind of starts. So for all the enemies in enemies, which is a vector again, I could be wrong. It's stored in the H. I'm pretty sure it's a vector of enemies. So for each enemy in enemies, it will scroll through and they will look for all the players in the room. So what they'll do is they'll check. Sorry, it happens later on. I'll show you. So for each player in the room, so we'll get the first player. If the room is empty, it'll just skip on and it won't attack anyone. But if there are enemies in the room, it will find the first one it can, and the enemy will attack it. So it will go enemy attack, which is feature here. So it's similar to the player attack. So what it does is it checks if the player's hit. So it calls this feature that this program that this function that Lucas has created called getRandomMT 19937. It's really nice code. It's like a really good way to get a uniform distribution randomization. So it's almost totally random every time. It's totally random every time. So what it does is it finds a value randomly generates a value between 0 and 20, and it checks this against if it's equal to or less than the 7. 7 is just hard coded at the minute because it was a good number to test, but we're gonna change that using the player's agility and the enemy's agility. So what it does is it returns true or false. So it'll know if it hit the player or not, and then sorry, I went too far back. And then it will inflict damage to the player, which is very similar to how it calculates the damage for the player. If the enemy's strength is less than 0, it returns 0. If not, it makes sure that their strengths aren't the same, but if they are the same, it will return the strength, else it will do this. And again, if the player's strength is less than 0, or is equal to 0, it will bug out here, so we have to fix that later on. Then it will inflict the damage to the player, which is the same. It will just set the player's current health to current health minus damage, and then it would send a string to the player to tell them that they were hit by a certain enemy for a certain amount of health. And then it will check if the player is dead. So how this works is it goes into the player .cpp, and if their base stats are less than or equal to 0, it will basically announce to everyone that they got knocked out, just to add insult to injury. And then we'll call the respawn feature. So how the respawn feature is, it sets your current health to your maximum health, so you're fully revived. It will remove you from the room you're in, like before. It'll basically set you to a different room, and it always restores you to the main room, the common room, the front hall. And then it will print out the room so that you know where you are. You could see it when Paddy got knocked out. Even though it says Lucas, I talked about it. Anna could see that Paddy was knocked out, but Paddy was told he was knocked out and he was moved to the front hall. And I think that's it, almost done. Too far. So yeah. If this returns true, it will say this is just a debug. It will check that the player died during attack, and if not, no one died. But here it breaks out, because if it didn't, this would crash, because you can't change the size of a list during an auto for loop. So you have to break out, so it stops all this. And I think that is everything yeah. That's all I've talked about. So that's all I worked on. So I'm gonna pass you on to Lucas now.